So this is part 2 of the 5.6 video where we're going to look and see what special happens with the 45, 45, 90 triangle. So again, you can kind of picture this triangle on the XY axis where the 45-degree angle would be theta. And again, we know that the radius of that circle is going to be 1 unit long. And so we have to figure out how long is that opposite side and how long is the adjacent side. Well, when you have two 45-degree angles, then you know you've got an isosceles triangle, because when two angles are congruent, then two side lengths have to be congruent. So I don't know how long that side is, I'll call it x, but I do know that it has to be the same on the other side. So when I'm solving my equation, I can say that 1 squared, my radius squared, has to equal the square root of x squared plus x squared. So when we solve, square it to get rid of the square roots. Oops, I'm sorry. Now we write squared. Either way, you end up with 1. And now you've got x squared plus x squared, but I'd rather write that as 2x squared. So I can get my x by itself by dividing by 2 first. So now I have 1/2 equals x squared. How do we solve for x? I have to take the square root. So that means that x equals square root of 1/2. And again, we can split that up so that it's the square root of 1 over the square root of 2, or 1 divided by the square root of 2. I don't like that square root in the denominator. We need to rationalize the denominator, so I'm going to multiply the top and the bottom by the square root of 2, and I end up with the square root of 2 over 2. So that is how long x has to be. This side has to be square root of 2 over 2. And this vertical side, y, has to also be the square root of 2 over 2. If we're going to convert degrees to radians, I believe that one is pi over 4. That should be one that you've got memorized or close to memorized. And now for sine, cosine, and tangent, sine of this angle being the opposite over the hypotenuse. Opposite over hypotenuse is just going to be square root of 2 over 2. Cosine is the same value. Because those two sides are the same length, my x value and my y value are the same. So we get square root of 2 over 2 over 1, doesn't change it. And then for the tangent, this one could be ugly. Because tangent is opposite over adjacent, the tangent would have to be the square root of 2 over 2 all over the square root of 2 over 2. And actually, instead of multiplying by the reciprocal and doing all that stuff, if these two sides are the exact same length, then when I take one side and divide it by the other side, I've got the same number on the numerator and the denominator, and so anything divided by itself is going to be 1. So the tangent of 45 degrees is going to be 1, and you can type that into your calculator and double check that you get the same thing. And for that matter, you can double check sine and cosine as well. Type in the square root of 2 over 2, and you'll get that decimal answer, and then type in the sine of 45 degrees or the cosine of 45 degrees and make sure you get the same measure. Okay. There is a trick to being able to memorize sine, cosine, tangents for 45 degrees and then the 30 and 60. And so what I would like you to do, it's called the left-hand trick. I would like you to go to YouTube and watch this video. So type in trig and the awesome left hand, and you'll probably get some ads that pop up, but it should be towards the top, and watch this video.